So I'm really happy to kick off this security session this year, as pointed out, topic of clear importance and centric to robotics. And I'll be speaking about how to protect robot endpoints, robot devices out there being used in real applications. Now, this speech is supported by Alias, the company I'm working with, which essentially brings up about a decade of experience in robotics doing system integration and serving solutions to clients, and brings it down to security. We've been for quite a while working with ROS across different companies and across building and serving different robots. And here are some of the projects that we've lately been involved with. Some of these companies may sound familiar to you. Some of them are pretty big, actually. Here is an example of a client we have engaged with this year, 2020, in the midst of the pandemic, to be honest. This client is making springs for healthcare and automotive applications in pretty sensitive scenarios, I must say. And we're protecting their robots by installing our solution, our robot immune system, directly into the robot. RIS, or our robot immune system, protects the robot by learning about the interactions it typically has and adapting to the particular use case, ensuring that the robotic applications overall remain secure with our constant updates. And speaking about updates, we need to speak about what security really is about, which is a continuous flow and not just a product that you sell once and you go. Security is a process, one that needs to be reviewed constantly, and that needs to actually happen over the different phases of the life cycle of a product or a process. Alias has been working really hard over the last few years. We've been especially active this year, and we're happy to share that we have collected, archived, and cataloged more than 1,000 vulnerabilities for different technologies, all robotic technologies. Out of this more than 1,000, actually we disclosed back to the community openly more than 200, which we put out there in the robot vulnerability database. Thanks a lot for all of these organizations and projects that supported us in the process. We're very, very thankful. Without them, this wouldn't be possible. So thank you once again. And it also has allowed us to serve about 20 companies so far, each one of these with multiple robots in most of the cases. So very, very exciting. Now, when we think about security in robotics, we need to speak about the robotics stack, what our roboticist essentially has at hand and what it uses to build robot applications. ROS, of course, is at the core of most of us roboticists building robot applications. But as you can see, ROS is actually surrounded by more layers, more software and even hardware layers sometimes. So more things need to be considered when we think about security. The best way to realize this in the ROS world is analyzing the ROS computational model or the ROS computational graph. Most of you may probably know that there's essentially 3 APIs in the ROS world. These APIs allow interaction amongst entities within ROS across different protocols, across different types of elements which happen at the network level. Each one of these elements needs to be considered individually, which leads us to conclude that actually we cannot just focus on ROS. Security is an end-to-end effort, especially when securing the robotics stack. And this is what we've been doing for quite a while already. Quite a while ago, actually, we started with this, and one of the first steps we took was building a package dissector and crafter, one that tried to look at the robotics stack, not just at one specific layer, but covering as many as we could. So we built this and we started testing. We started doing static analysis, dynamic analysis. Within dynamic analysis, we did lots of fast testing, which, by the way, was mentioned in the quality session, which I very much encourage you to watch afterwards if you haven't. And we found interesting stuff, some of which we have disclosed, but certainly much, much more that still needs to be patched and mitigated. Here are some of the examples. This flaw, for example, affects versions prior to Jade, including Indigo and many others, and allows an attacker to craft a package, send it to ROS master, and directly crash it, essentially because it exploits a vulnerability in XML, RPC, which forces the ROS master to build a networking package which is huge, and while doing so, essentially it crashes, as you can see over here. So this particular attack, POC, tackles upper layers of the robotics stack. This one shows how a functionality in ROS, actually it's a functionality, this is applicable to all ROS versions, including the latest ones, and Noetic. And this functionality is something called shutdown, which isn't very well documented, but it's available if you do code analysis. And it allows an attacker, without any requirements for authentication or authorization, to simply just craft a package, send it up to the master, and literally close it, as you can see over there, with a very nice message in this case. And once again, this applies to lots of systems. This last example that I'm showing here tackles some of the flaws in the underlying layers below ROS TCP particularly. And the reason why we can execute this is because we are not really using sessions as much as we could within ROS TCP. And this empowers attackers to essentially understand the flow with these dissectors I mentioned before, and craft packages which disturb the communication. You can see over there how the average rate, which should be at 10 hertz, is being disrupted. And this could go down as much as the attacker wants, actually, if he or she selects the right packages or crafts them, better said. So you might be wondering, all right, this is interesting, but is it really applicable to real systems? Well, here's an example. This is a real working system that today is up in the cloud. It's accessible, and it is actually subject to some of the vulnerabilities that I've just shown, and many more we have internally registered. The interesting thing is that this system actually includes a host-based firewall, which to some is the panacea, but clearly it doesn't contain many of the existing attacks one could execute. And funny fact actually is that this is a reasonably popular company. It has raised a decent amount of resources. Still, security seems to be a pending aspect, so very much work to do, and very much needed that all of you engage into security as soon as possible. We went out there and we wanted to dive a bit further, so we went and reached out and tried to search for ROS in the wild. Some of this data, we presented it a year and a couple of years ago when we started doing scannings for ROS systems, classifying them between empty, real, and simulations that we could identify. This year, we're bringing you one step further, which is exactly how do they categorize based on ROS versions. And the interesting thing here is not so much the distribution, which I know is a huge topic of discussion now in this course. I won't get into that. But I will tell you that about 1/5 of the ROS machines which today are out there in the internet are using end-of-life versions. And even if this sounds impressive to you, it is not at all in the industry. It's very common to find in industry systems that are already in end of life, nobody's giving support. So this is something we're going to increasingly see. And take a look, 54% uses kinetic, which by the way is not so far from being end of life. So definitely security solutions are required. And that's where we have been working for the past period. And we're very proud to share that our robot immune system, our smart antivirus for robots, now offers support for 2 ROS 1 versions, for ROS kinetic and ROS melodic. In a nutshell, the robot immune system offers these 5 capabilities. The first thing is, thanks to the fact that we do proactive research in security, in offensive security, we're able to create adaptive firewalls with these package crafters and dissectors. These adaptive firewalls are able to understand the logic, the flow of the computational graph, and thereby propose proper mechanisms for perimeters. Second module is a hardening module based on the vulnerabilities we identify, both ourselves and other groups which we register. We develop mitigations which we then zip into RIS. Logging, we do secure logging for forensic purposes. We store logs using cryptography, which allows us to essentially make sure that when something goes wrong, it's traceable. We also include some visualization capabilities which allow you to introspect the ROS computational graph using the ROS abstraction, something that becomes pretty handy if you're assessing a system remotely. And finally, we use some really simple machine learning techniques which allow us to generalize and try to essentially frustrate attacks that haven't been fully seen using some of these techniques. At this point of the presentation, you might be wondering, well, I've got a ROS system, so maybe I can just use your solution and that's it, right? I'm secure. That might not be it. From our research, we found actually that all of these robots use ROS, in particular ROS Kinetic, to be very transparent. And the interesting thing is that when we pen tested them, we found more security flaws in underlying and above layers than ROS than in ROS itself. So this directly correlates with the fact that these systems require a specific solution for each one of them, a robot endpoint security solution. And that's the main topic actually I'd like to share with you, something we've put lots of resources and effort into it. And essentially the need of this doesn't just come from the fact that we do proactive security research and have findings, it also comes from normative requirements. If you take a look out there, you'll see an increasing amount of organizations which are acknowledging that safety requires security. Robotic systems are only safe if they are secure. And actually safety requirements spawn from security research. If you want to dive further into these topics, we recommend you to take a look at these three sources. The first one is the meta standard for functional safety, the IEC 61508, which already mentions, by the way, some very interesting approaches which should be taken with regard to cybersecurity. The second one is the IEC 62443, the cybersecurity standard for industry, something we're very close to lately. And the final one, which actually hasn't been fully released just yet, is the new European Machine Directive. There's a preliminary draft, and it already mentions that cybersecurity will be considered a prerequisite. So pretty exciting things coming out in 2021 with regard to cybersecurity. We look forward to it. It wasn't enough, though, for us, for our team, to do this research. We wanted to experimentally validate it. So that's also something we did. We grabbed some of the best-selling and most popular robots in Europe and in the world, and we essentially conducted proof-of-concept attacks, validating the fact that an attacker could take control of them, could inject ransomware remotely, and could even frustrate the safety systems, disabling it, forcing the robot to collide with itself or with other objects, as you can see, for example, over there. Bringing this all to industry means that these systems need to be protected immediately. So we started acquiring considerations that came from customers and brought essentially the following ones. Systems in industry, systems and robotic processes using robots mostly use security solutions, if they use security solutions that do monitor. They do intrusion detection mostly. Access control and perimeters are static, and this somehow conflicts with some of those claims that host-based firewalls are the solution for everything. Well, unfortunately, they are not, and these static perimeters often conflict with even the computational graph abstractions that ROS proposes. So this is an issue. Endpoints aren't typically secured as part of these industrial security solutions. They are pretty much left aside, guessed as simple PLCs, which only require some integrity checks at best. There's no real security measure for them. Most often, these production systems have very long life cycles, and they are assumed to be secured when they are secured with Castellan mode models, which mean that insider threats aren't considered really. We were very scared when we saw all of this, very, very scared. So our reaction was to reach out our network and try to partner with someone that could help us deliver a solution that could help real industries out there. And that's how we ended up partnering with Kaspersky, one of the big companies in the world doing cybersecurity. And together with them, together with their solutions, we developed a coordinated solution which allows to use our robot immune system in coordination with their Kaspersky industrial cybersecurity solution to protect both ICS environments together with their robots. Not just protect them, but also monitor, control, update, and manage them. With this partnership, we managed to make sure that security can be centralized in the Kaspersky management computers, basically. And from there, you can interact with all secured systems, including those ones with our robot immune system. So it was very exciting, but we've been very ambitious. This year, we've worked really hard, And last year, we showed to some of you, or maybe all of you, you're repeating this year again, that we had support for some of the robots from Universal Robots. This year, we're happy to share that we've gone and supported more than 46 robot endpoints, and this number is growing. We're extremely excited actually to share that we have provided support for many of the Kuka robots, offering security using all of our modules, from the visualization to the hardening, secure logging, and so on. You can see actually this video in our booth, so I encourage you to drop by and just say hi. Now, we are pretty happy with the essentially with what we've done so far and with our current solutions, but we want to be a bit more ambitious even, and we want to give you a sneak peek of what's coming real soon and in the coming months. The first thing is security certification. We're super happy to share that we've been working for a while in security certifying our robot immune system across all of our supported robots. We are now able to start committing to projects that require security certification according to ISA 62443. Particularly, we will be providing certification for part 4.2 with security level 1 for now. And we're working with a number of parties to do this from Spain, Germany, and Switzerland. So if security certification is something you care about, feel free to reach out. We can definitely help. The next thing we've been working on, and you will see more from us in the coming months, is ROS2, ROS2 efforts. We've been working really hard in ROS2, and contrary to what some believe in the community, thinking that ROS2 is the panacea for security and that you should move to ROS2 if you want to be secure. Well, ROS2 actually is not that mature from a security angle. And I'm not speaking about SROS. SROS2 is great, and the people behind it is awesome. I'm speaking about the underlying security primitives, the one that live inside of DDS, and particularly the DDS security plugins. These ones are still pretty immature. Most of the DDS vendors are implementing the first releases, and proper testing leads to finding quite a few flaws. To give you a sense of intuition, we currently have in our archive more zero-day vulnerabilities for ROS2 than for ROS1. If ROS2 is something you're considering, or you're already investing resources to safety over ROS2, we definitely encourage you to reach out and consider security immediately. We definitely can help. The last two bits, we're super excited to launch this partnership. Telefónica is one of the biggest Spanish companies, and actually one of the top telecommunication providers in the world. They are known as O2 in Germany, I believe. And we've partnered with Telefónica and will open up in 2021 a cybersecurity for robotics lab in Germany, in Munich particularly. We're super excited about this, and the topics we will be researching with their team include 4G, 5G, robotics, and cybersecurity. So if you're thinking about deploying robots in mobile networks, we definitely can help. Last but not least, we're very excited to share about this exciting project. There's not too many public details yet, but we'll be sharing more in the coming months, but we've partnered with public organizations in the European landscape, and we will deploy hundreds of instances of virtual robots throughout the internet. With these instances, which will include, by the way, ROS and physical robots, we will do it so that it's pretty hard to tell if it's a virtualization or a real robot. We're working hard on that, and we aim to collect lots of data with this, data about how attackers behave, and with this, serve everyone better and improve our defensive mechanisms. This is all so far for this year, quite a few things. Hope you enjoyed, and also hope you can enjoy the rest of the sessions. I think we have 2 more security sessions, very interesting, coming after myself. So with that, very happy to take questions. Stay safe and stay secure.